Hi, this is Adam from MakerState, and I'm here with our first webinar for the Maker Partnership Program. So this is webinar number 1, October 8th, 2018, and we're covering binary bracelets and just generally your first startup makerspace in general. So for your first makerspace, you might not be starting this week, and that's okay. It's not mandatory to start this week, so don't panic if you're not, but either way, you should be recruiting students and spreading the word about your program and getting ready to start in the next week or two, either way. And something that's just helpful is this Makerspace weekly challenge checklist over here that you can find in your resources from training. And this is just a really easy way to make sure you're ready to take on your Makerspace for the week, starting with prepping your lesson in STEM Collab. And if you're watching this webinar video, then you're already doing a good job of that, so congrats. And that's going to include, building your binary bracelet, which you have done in the trainings, but it's good to have a little refresher. And so that's your preparation. Then for Makerspace technology, there's not too much technology involved in this, but there are some materials that we'll talk about in a few minutes. You're going to want to print and prep your material supports, rubrics, challenge report, makerspace, folders, etc. Taking attendance, facilitating the makerspace, and then using your rubrics to monitor your students' progress, handing out your challenge reports that can go home with parents and school admins at the end of class, and then sharing your successes, failures, etc. on the STEM Collab using your prep and practice space, or by commenting on this video or commenting on the lesson page, or just sharing your thoughts on the collab. And so again, find all your resources in the STEM Collab, and we're going to go over there in a second just to look at where exactly to find all this stuff. And then so your Makerspace materials, you're going to want to bring your design cycle poster, your badges, your magnets, and then a few other things that are specific to this challenge, okay? So in your first makerspace, you might want to just begin by, giving an intro to your makerspace and talking about what it is that you're going to be doing after school, one day a week for the rest of the year. And hopefully you have some of your own ideas about, what you hope your students to accomplish in this makerspace and why you think the skills they're going to develop are important. What skills and processes do makers use? Well, this would be a good moment to introduce our engineering design cycle, the process by which engineers and makers create the solutions to our problems around the world, right? And you can also explain along with this the magnet use, the badging, and the rubrics, and how all of these things kind of work together to create this complete makerspace experience where we're going to work together and collaborate to learn these new technologies and skills and make things, right? You can also take a second here to reference the idea of computational thinking. You don't need to go super in depth into it, but maybe you can show that video if you're feeling like you have enough time to, and I'll link that video below this video. And just in general, explain that, computers are good at solving many problems for us, but we can actually learn something from the ways that computers solve problems and use these same skills ourselves to solve problems. And this is actually a really good segue into the whole idea of people programming, because people programming, these next few lessons that you're about to do, is all about just learning, is just about using these different computational thinking skills without using a computer, just to understand these processes, right? And with that, let's just take a quick look over at the collab here. So here's our page for binary bracelet, and I just want to draw your attention to this area right here, the links to your challenge materials, okay? So here is your challenge lesson plan, and that, when that opens, this is, your step-by-step lesson plan for this project. So what I'm going through right now is more or less what you have in this document to some extent, but I'm hopefully just adding a little bit more meat to it, or just a little more context to it. But in general, here you have all of your background information, your vocabulary terms, etc. Some opening questions or guiding questions for your circle meeting, along with these rubric moments here. So these, highlighted checkbox moments are important because that's when you know that something relating to your rubric is happening. Then your create steps, and these are the same steps that are outlined in the video, and etc. So just, be aware of all these things here in this challenge plan, in this lesson plan, I should say. Then you have your binary decoding chart. This is the piece of paper that you're going to hand out for students to start working on their bracelets, and this is how they're going to encode their names into binary using this chart. So make sure you have these printed out, and then your rubrics and your parent reports that are also going to go out, okay? And of course, here on this collab page, you have your video, which maybe you've already watched this if you're watching this one now, or you also have your quiz and your prep and practice prompts, which you can answer down here in this comment box, okay? So just be aware of all of that. Terrific. Okay, so let's go back to our slides. Great. So your first makerspace, you've introduced your makerspace, your design cycle, and your general makerspace protocols. Great. And now we're talking about people programming. So for the binary bracelets, you're going to need 20 to 40 beads per student. Remember, it's about 5 beads per letter. So if a student has more than 7 or 8 letters in their name, I might encourage them to use their initials or to pick a nickname or something like that. And of these beads, half of them are going to be white and half of them are going to be a mix of other colors. So the idea is that all of the zeros are going to be represented by white beads and the ones are going to be represented by another colored bead. Students can all pick another color to be their ones, right? Then you're going to have your 1 foot of elastic cord per student. You can cut that ahead of time to save some time. And your binary decoding charts, which I just pointed out, you find them through the collab, and then your rubric and parent report. Okay, so here we are now in the discover phase of our binary bracelets challenge, and you're probably already in your circle meeting if you've been talking about introducing your makerspace and things like that. But now you can go through your STEM idea and your keywords, and again, the definitions for all of these are all there in the lesson plan. But in general, this challenge is not about becoming expert binary readers. Binary is not a particularly useful language for humans to use most of the time. It's more just about this idea of how information can be encoded into different code systems that might be useful to make it stored on a computer, for example. We're going to talk more about how binary relates to a computer in just a moment. But the idea that we do want to get across that information is stored using codes, and codes allow information to be transferred easier or stored easier or transmitted in secret, etc., right? And at this point, you can introduce your keywords and your challenge question and maybe even your own prototype of your binary bracelet if you have it on. Okay? So I just want to dive in for a second and talk about how binary relates to computers. This was a question that I feel like came up a lot in our trainings, and I just want to take a minute or two to dive into that. Even if you don't go this deep with your students, I'm sure your students might have some questions, and maybe you can find a way to make this information useful to them. So information is stored in a computer's hardware using billions of tiny electrical switches called transistors. An iPhone 8, I was just reading, has somewhere in the ballpark of 8 billion transistors in it. And these transistors, again, are just very tiny little switches. And just like a light switch, they can either be on or off. They can't be in between on or off. They can just be on, which we represent with a 1, or off, which we represent with a 0. So, hence the need to store info with only 1s and 0s. Deep down in the hardware of a computer, 1s and 0s are all a computer has. They just have switches that are on or off, right? And so binary is what we might call a machine language or a machine code, meaning that it interfaces directly with the computer's hardware, with the machine's hardware, and is really only useful for the machine or the computer. And I really like this graphic right here. And what this graphic is showing is that a high-level language, which are the languages, computer programming language that you hear more about, Java and JavaScript and Python and C, etc. Those languages, that are written by humans are translated down kind of through this hierarchy of more and more machine-friendly languages. So, if we were to kind of draw a scale on this, up here at the top of the chart is languages that are useful for people to write and read, but not as useful for computer hardware to write and read. And then as we go down, that balance shifts, and people, cannot really read assembly language or machine code very easily at all without a lot of painstaking effort. But that's the code that can actually communicate directly with the computer hardware. If I were to add another, If I were to add another, box up here, I'd probably write human language, because that's the thing that really precedes, this high-level computer language. The first thing that happens is you have an idea in your own language. For us, it's English. And you'd say, okay, I have my idea in English. Now I need to translate that idea to a computer language that a computer can start to understand and translate down to its hardware. So we'd start with a human language up here, then a high-level programming language, C, Java, etc. An assembly language is somewhere a little bit in between, which I'm not going to get super into right now, but it's relatively unreadable, but a little bit more readable than just ones and zeros. And then finally we get down to machine code, which is usually some form of binary, okay, through which the computer the program can communicate directly with the computer's hardware. Okay, so now once you get through that overview, and again, you don't go as deep into that with your students as you think will be useful for them. But anyway, after that, we're in our create phase, and all the instructions for the create phase, again, are in the video and in the lesson plan, so I'm not going to go super deep into this, but you're going to start with that binary encoding key, and in pairs, encode names into binary, right? So start with your name in your high-level language. So almost this, this little diagram right here is almost similar to this diagram right here. We're starting with our English, right? With our high-level language, and then we're moving into this decimal language, right? This our comfortable 10-bit number or 10, base number system, which us as humans are relatively comfortable with. Maybe not comfortable using instead of words or letters, but we can still figure it out. And then from there, translating down into our machine language, so to speak, which are just our ones and zeros. Okay. So anyway, you're starting with that binary key to encode your name into binary, and then you're going to lay out your beads underneath your binary before stringing them on your bracelet. And just your general rules for the beads: you're using 5 beads for every letter. You're using white beads for zeros and a colored bead of the student's choice for the ones. And then you need to take a third colored bead, see this orange one right here, and stick it at the front of your beads to represent the start, because once you put this on a circular bracelet, you need to know where your name begins and ends, right? So I'm using this orange bead, a third colored bead, to signify that start. Have students check another student's work, at really every one of these steps, in my opinion, as often as possible, just to make sure that we, get the right codes at the end of this. And once a student, verifies that another student has correctly laid out their beads, then we can transfer to the string and tie the knot. And just some general tips. So check each other's work often, as I said before. Tape one end of your string down when transferring the beads. That I find, so if you tape one end of the string down on the desk, the beads won't fall off the other end as you string them along, which is good. And if full names are too long, you can use nicknames, you can use initials, you can use the name of the school, or you can have students pick another word to use. So they don't have to do their names, but that that made sense to me. But if you can think of another word, or if it just is easier for everyone to do the same word, so you want to do your school's name or just initials, so everyone's using 2 or 3 letters, those are all fine hacks that you can do on this. Once you're done with that, then you're going to move on to the improve phase. And the improve phase for this is really improving our skills at decoding this binary, and just kind of a fun way to check whether or not how effective this was. So students, I would collect all the bracelets and put them on a table somewhere, and have students take one another's bracelets at random and see if everyone can get their bracelets back to the original person by decoding the name off of the bracelet from the beads, right? So that's going to be a fun challenge for your students. It will be challenging, and I bet that your students will have some realizations about what it means to encode and decode this binary code. And these you can address in your circle debrief. So maybe your students will have some thoughts about things that could have been done to make the decoding easier, or some other thoughts about how this applies to computers translating information, right? So you want to do your circle debrief, get your students' feedback and about their experience, and then send them off with their parent reports. And then afterwards, you want to come back to the STEM collab and report on that experience, right? And it's specifically in that prep and practice section on the collab, at which point you are ready to start prepping for drawing machine next week. Okay, so that's more or less going to do it for this webinar. I hope I've given you some fodder for your discover section, and for just some general tips for leading through this makerspace. I'm sure these webinars will get a little bit longer as we see some of your makerspaces in action and have things to reflect on and respond to. But our trainings were so recently that I feel like I don't have a ton more to go into right now. So I hope that this was informative, and I'm going to link some other outside videos and resources as I discussed below this video, so check those out there. But thank you for watching, and I'll see you back for the next one. Thanks. Bye.